Okay guys, it's graphics guy. Just have a quick look here at 2010 section B higher level. So we've got two planes here, ABC and ABD. So you're asked to draw the plane and elevation, which I've done. So the first thing you're asked to do there is determine the dihedral angle. So what I'm going to do here is I'm going to put the line of intersection in red. Okay, now I'm always saying that it's so much easier if you use colors to help you see these things. So there's our line of intersection in red. So what we want to do is we want to take an auxiliary view to see the true length of the line of intersection. Now, since I don't have room to look up this way, I'm going to project down in this direction. So here's my there's my XY line. This is XY1. So we just project these down here. Okay. So I'll just extend these down another small bit. Now two of these are along the same line, but it doesn't make a difference. So now I'm just checking the heights there. So I know the heights anyway in this. A is up 20. So whatever the height is above the ground here is the same down in this view. So A is 20 above the ground. And B is 60 above the ground. And D is 70. And C is 20 also. So the most important one here is the AB line, because I wanted the true length of that. I'm just going to stick a TL for true length on that. So I'll just complete these planes again. So there's ABC. And here's ABD. Now I've got a true length of the line of intersection. I want to look along that true length. So I want to look along it. So we're projecting them out at this angle. So here's my next XY line. Just label that XY2. Okay. Okay, so one rule of projections, like we're doing here, is whenever you're projecting from a view, it's from the last XY line back. So we're projecting from here, so the last XY line back. That's where we're taking our distances. So since we looked parallel to the line of intersection, so A and B are the same distance. So that's why this works. So that is giving me here now a point view. It's important that this is red now. So that's a point view of A and B. So C is about 4 millimeters. Okay, and D So there we have there's an edge view of plane. That's an edge view of ABC, and that's an edge view of ABC. This is an edge view of ABD. So we now have A done was the elevation and plan. The dihedral angle is done. So the next thing they wanted then was the true shape of ABC. Now, the easiest way to do the true shape of any of these is when you have the dihedral angle, if you look at 90 degrees, that's an edge view of the plane. So if you look at 90 degrees to that, you will see the true shape of that plane. So that works always. If you have the dihedral angle and they want the true shape of one of those planes, that's a pretty simple way of doing it. So I just put our next XY line here, which is 1, 2, XY 3. So I'm projecting out at 90 degrees, so I'm going to look at the true shape of that plane. So we're projecting from here, so the last XY line back. So that's my distance for B. That's A, that's B. And C. So since AB is the line of intersection, that was red. So I'm just going to put TS for true shape on that. So that's true shape of ABC. And the next thing I wanted then was the traces of the plane that contains ABC. Okay, so basically what they're saying here is ABC is a triangle that's hovering up in the air. It's like floating in the air. So if you extended that plane down to the ground, where does it cut through the horizontal plane? So the easiest way to do this, and this is quite straightforward, if we extend BC down to the ground, that's where BC hits the ground. I'm going to project that down. And when I extend BC, now I already kind of had done that. So that here, I'll use green maybe for this. That is 1 point on the horizontal trace. So now on the other side here, I'm going to extend AB down. Project that down. Extend A, well it's BA I suppose technically, extend BA, and that's the other point. So I'm going to put this in using green, I think. So HT for horizontal trace, which is where that triangle cuts through the horizontal plane. Now, pretty much similar to that there then, slightly harder maybe to picture it. I'm going to just adjust the angle of this up here now a little bit. I'm going to be extending then AB into the vertical plane. Now you must picture the vertical plane standing up here vertical as we look down on it. So when you extend AB up here, that's where it would be hitting the vertical plane. So when I extend this, oh god, it's gone off the sheet. Oh, that's a mess now. Okay. So, and it'll be the same then going the other direction. So, now if that was to happen in an exam, okay, so here, when I extend CB, okay, so if that were to happen in an exam, like what would you do about it? I would measure the distance here, which is 15 mil, and I would just say, okay, so the vertical trace 15 millimeters off the sheet. Now you wouldn't lose any marks for that, because, or the other thing you could do is you could just add an extra sheet, just stick on a bit there underneath it and tape it on there and draw it out there. It's probably a better way of doing it, but these things happen. But the marks in the exam are for effort or for method, so it's not as if you're going to get nothing for that. You'd get full marks for it. So that's the final part there, the traces that contain ABC.